Well, so kind of a continuation. I know we're in 3.3, but kind of a continuation of 3.2, just so that we're clear about this domain, discrete, continuous, how to relate all that. On number 9 is the domain. So which one's domain, X or Y?
X.
X. Okay. Is the domain discrete or continuous? How many say discrete? How many say continuous? How many say discrete? You got to pick one. How many say continuous? Okay. Number of stories and height of the building. That is, describe, go ahead and tell your neighbor why you think it's discrete or continuous. I'm curious.
You can't have half a floor. If you're building a building, you can have half a floor. But I don't think they're talking about a half-built building.
I don't think they want a half-built building.
No. Half-built buildings are not safe to live in.
Okay. Once again, how many say discrete? Just curious. How many say continuous? Okay, it is discrete. Why is it discrete? Sarah. Okay, the story or the floor number has to be a whole number. Okay, you don't have like the 2.5 floor. Like we are not, like Caballero has 2 floors, it has a first floor and a second floor. We're not going to call half a floors. Now some of you I know will get like smarty pants with me. You'll be like, well, what if you like go like halfway up the stairs and then you have to change position? They're like at 1.5. I know, like that. Okay, I get all that, but that's not what we're talking about. Yes. Okay, so you have a first floor, a second floor, a third floor, and so on. Okay, so no half of a floor. All right. Now, moving on to number 10. A 20-gallon bathtub is draining at a rate of 2.5 gallons per minute. The number of gallons G remaining is a function of the number of minutes. Does this situation represent a linear function? Explain. What do you guys think? Who says, yep, it represents linear? Who says, nope, does not represent linear? Why? Some of you didn't even vote. Who says yes? No? Why is it linear? So it looks like most of you said yes. How come? Yeah, Kai? There's no equation. Okay, what equation did you come up with? Like that? Oh, plus 20? I'm sorry, I didn't hear the plus 20. How many have something like that? Okay, did anyone change that? Like, what would Y actually be in context? Jillian? G. So the gallons remaining. Okay, is equal to negative 2.5. What's X mean? Okay, minutes plus 20. Did anyone put the 20 first? Say 20 minus 2.5 in? Okay, we could have done that. All right, so this is linear because you can write it in y equals mx plus b format. Okay? It has a, yeah. Okay, hold on one second. It has a constant rate of change, right? That's another way to think about it. When you are doing something at a constant rate of change, in this case 2.5, the word per, that keys you in that that's a rate. So those of you that really don't get this, making sure that you understand that when you see like gallons per minute, miles per hour, something per something, cost per pound, something like that, that's a rate. And that rate is what we use when we're dealing with linear equations in this chapter here. All right, Sarah, what do you got?
It says the number of gallons remaining is a function of the number n, so wouldn't it be g of n?
Yeah, so you could, yes, you could write it as a function. In function notation, you could say g of m equals negative 2.5 m. Yeah, and since we're dealing with functions, that would probably be a good idea. Okay. All right. Find the domain of the function. So once again, when we're thinking domain, and you guys are doing this on your quizzes, and you're trying to graph this stuff, if I have an xy axis, when I'm dealing with x, x in context of this problem is what thing? What label is x? Okay, what are my two variables? Minutes and gallons. So is x minutes or is x gallons? X is minutes. So that means y is gallons. Okay? So we've got to ask ourselves, okay, thinking back to what we've been talking about, this right here is plus plus, minus plus. What's this one? Minus minus and plus minus. We're talking x and y. So you could have positive minutes and positive gallons. Can you have negative minutes? No. So our graph will not exist over here.
It's going to be a line.
Can you have negative minutes? No. It's not going to exist anywhere here. Can you have positive minutes? Can you have negative gallons? No.
Looks like it's going to be a line segment because it's also going down.
Okay, but this will help us with our domain, right? So what is the domain? Well, the domain, could I have 0? Yeah, domain stands for minutes in this case. I could have 0 minutes. So my domain is m has to be Okay, so we're saying greater than or equal to 0, which means that that would mean this is continuous data. Right? If we use an inequality symbol, that means we're automatically saying it's continuous. Is that true? Bailey?
It also have to be less than or equal to 8.
Okay, hold on 1 second. Let's go back to that. Okay? Is this continuous? What do you think, Logan? Continuous? Okay, we talked that linear can have discrete, right? It's just the dots are in a straight line. Okay? Why is this continuous? Jason?
Because you can have a fraction of gallons and a fraction of minutes.
Good, and we're not worried so much about the gallons, but you can have fractional minutes in this. You can have like 1.5 minutes. 1 3/4 of a minute.
1/1000.
Okay? You can have partial minutes. Therefore, this is continuous. And when we write it like this, we're automatically saying it's continuous, but I want you to say, hey, this is continuous data. Okay, now Bailey's trying to add to our domain. Bailey, can we add to that after we start graphing it? Okay, I think you've got the right idea there. But we've got gallons, and I'm going to put up my graph here. I think I have it. Maybe I don't have one. I do have it. That's the graph I get. Total yay. Okay, so in terms of this, I have g of m is equal to negative 2.5 m plus 20. How did I get that? Well, I made my table. G of m, or excuse me, m on this side. Negative 2.5 m plus 20. And then this is g of m. So we have outputs and inputs. And I know that based upon what we did right here, I know that my starting point for the minutes should be 0. And then it has to be positive minutes from there. Okay, well, if I put 0 in here, negative 2.5 times 0 is it's 20. That's where I get that dot there. And then I keep doing that. I get negative 2.5 times 1 plus 20. Tell your neighbor what that is. Okay, 17.5. What's the, when 2, what do we get? 15, and then? Okay, so here becomes the question, and I think this is where Bailey got his info. Eventually, you're going to run out of what? You're going to run out of the 20 gallons you started with, right? I mean, you're draining a bathtub. Eventually, you run out of water. So at what point do you run out of water is the question.
This is really big bathtub, 20 gallons per minute.
No, it's 20-gallon tub, losing 2.5 gallons per minute. So we keep going. We get 12.5. We can follow the pattern now because it's linear. This is 10, 7.5, 5, 2.5, and 0 gallons. So what Bailey was saying, when we graph it, it stops here. Notice there aren't arrows on the end. It starts here, it ends here. You can't put arrows because it doesn't exist down here and up here. Okay, so our domain is actually m is greater than or equal to 0, but m is also less than or equal to 8. So we could write that as this. That is our actual domain. Okay, good job. Any questions? Guys, that's some major stuff. And why do I keep doing these problems off 3.2? Well, what do you have tomorrow? A quiz. Are we in 3.2 right now? No, we're on 3.3. But we need to understand the function notation for here. Okay. Any other questions? Why don't you guys take out yesterday's assignment, please?